Hey everybody, in Honors Pre-Calc today we're going to be finishing up the lesson 5.2 notes on trig graph transformations. We already talked about sine, cosine, cosecant, and secant. So today we're going to be wrapping that up with tangent and cotangent. And because tangent and cotangent are not fully related to sine or cosine, it's going to be a little bit different. So to kind of ease things a little bit, we're only going to be looking at really amplitude, or really the vertical stretch or shrink here, and the period, or the horizontal stretch or shrink. So that's the two things we're going to be focusing on. We're only going to be looking at A values and B values for tangent and cotangent. Just to remind you, and I encourage you to have this out, if you look at your 5.1 notes, here's a reminder of what tangent looks like. So the period is pi. It's going to go from negative pi over 2 to pi over 2. And the 5 key points are going to be important here. So it's centered at 0. It goes from negative pi over 2 to pi over 2 for the x values. The y values are first just a vertical asymptote. It's not even really a point, the first key point. Second one is at -1, then 0, then +1 for the y values. And that's the chart that we're going to use when we create transformed versions of tangent. And I want to show you this digitally on Desmos first. So let me pause and get you that screen. All right, so here's an example of tangent. You can see I'm graphing y equals a tangent of bx. Like I said, we're only going to be looking at changes to a and b for tangent. And so here's the first period from negative pi over 2 to pi over 2. We're centered at 0, 0. And you can see that right now at pi over 4, we have a y value of 1. At negative pi over 4, we have a y value of -1. These equations, the second and third thing here, are just my way of showing the vertical asymptotes. You don't need to kind of write that down or memorize that idea. So just ignore that idea for now. I'm just going to use this slider to change A. So what happens when I change A? Take a look. So as I increase the A, the graph is getting stretched vertically. As I decrease A, we're getting compressed vertically until I get to the negatives, then the whole graph flipped upside down. So again, this was the parent graph with an A of 1. If I have A of -1, you can see the whole thing flips upside down. None of this is changing the period, right? From negative pi over 2 to pi over 2 didn't change when I changed to A. So A is just kind of stretching. We're used to A stretching vertically. The amplitude for a wave stretched or compressed vertically. For a tangent function, we don't really have something called an amplitude because this isn't a wave function. So we're just going to call it a vertical stretch or shrink. For B, the B value, we're used to changing the period, and that's going to do something similar here. So watch as I increase B, see what happens. As I increase B, the period is shrinking, but notice that it's still centered at 0. So just like the other trig functions, it's anchored at 0. This time the period, though, kind of increases or decreases in both directions. So I'll show you how we do that when we get to the notes. But I just wanted you to see some of this visually first. So those are the only two transformations we're going to be looking at. Okay, so let's switch back over to the notes. All right, so we're looking at example 6, sketching graph of a tangent function. There are a couple differences between this and our original sine and cosine transformation. So I want you to write this down at the top of the page or in your notes somewhere. The amplitude in this case is similar, but it's called the vertical stretch or shrink instead. The period is going to be pi over b instead of 2 pi over b. And that's because the parent graph period for sine is 2 pi. The parent graph period for tangent is pi. So we just do pi over b instead of 2 pi over b. And finally, tangent is always centered at x equals 0. Then we just have to go half the length of the period in both directions. And that will give us a full period from one end to the other with 0 in the middle. So that's what we're going to try here. So let's look at letter A together. Make sure you have that all written down. We're going to sketch y equals tangent of x over 2. And as I said, we're only going to have A and B values here. So in this first question, we have an A of 1. That's the number that's in front of tangent. And we have a B of 1/2. Then that's going to tell us the vertical stretch or shrink and the period. So I'm going to write that as vertical stretch, and the period, which we know is pi over b this time. So it's going to be pi over 1/2, or pi times 2 over 1. So it's going to be 2 pi. So now I'm going to make my chart of 5 key values. And like I said, tangent is always centered at x equals 0. So we're going to make the middle x value 0. And since the period is 2 pi, we're going to go a length of pi in both directions from 0. So I'm going to go from 0 to pi. And on the left, it'll be from to negative pi. And now if you combine that, from negative pi to pi is a total distance of 2 pi, which is our period. So we know it worked. Then we have to split that interval completely into fourths. So from 0 to pi, halfway between is pi over 2. From 0 to negative pi, halfway between is negative pi over 2. And now let's take a look at the y values. If you take a look at the parent graph for tangent, we started with a vertical asymptote. Then we have a y value of -1, then 0, then 1. All of those are going to get multiplied by our a when we rewrite them here. And in this question, a was 1. So there was no change to the vertical values. These y values are going to be the same as the parent. So it'll be, first, I'm just going to write it as vertical asymptote. And then -1, 0, 1, vertical asymptote. Okay, so now we're just going to sketch that. So first, I'm going to make my vertical lines for my vertical asymptotes at negative pi and pi. And then I'm going to plot the points and connect them. So negative pi over 2 is down at -1, 0, 0, pi over 2, 1. And I'm going to try to sketch this so that it looks as close to what a tangent looks like as possible. So it's going to start going this direction and then curve up, and this direction and curve down. Something like that, okay? Now keep in mind that's just one period, so that exact pattern is going to repeat again and again and again if we drew more of the graph. But we don't need to, we only need to make one period. Okay, so let's try letter B. Same idea, so we're going to start by identifying A and B. This time A is -3, because it's whatever's in front of the tangent, and the B is 2. So that means our vertical stretch this time is technically -3. The amplitude is the absolute value of A for vertical stretch. We don't really need to take the absolute value. And we know that a -3 is going to flip us upside down and stretch by a factor of 3. And we'll be able to see that on the graph in a second. The period is going to be pi over B, which this time is pi over 2, because B was 2. So let's make our chart of 5 key points. I know that I'm centered at 0. Let's split our period in half. Half of pi over 2 is pi over 4. It's just like saying half of a half is a fourth. And so I'm going to go pi over 4 in either direction from the 0. So I'm going to get to pi over 4 and negative pi over 4. And now you notice that from negative pi over 4 to pi over 4, the total length is pi over 2, which is the period. So that worked. I'm going to split the upper region in half and the lower region in half. And now I'm going to look at the y values. I'm going to take the parent y values and multiply them all by -3. Vertical asymptote stays vertical asymptote. -1 times -3 is going to be +3. Then 0, then -3, and then vertical asymptote again. It's hard for me to show you all of that on one screen, but here's the tangent originally. -1 times -3 gave 3. 0 times 0 is, well, 0 times -3 is 0. 1 times -3 is -3. So that's where we get those. Then we come down here to the graph. I'm going to make the vertical asymptotes first. Plot the points. And notice that instead of going up like your typical tangent, this one's going to be going down. But I still wanted to have that tangent-like curve to it. All right. There we go. So it got stretched vertically and flipped. And I guess it shrunk horizontally, or compressed horizontally. But there we go. So that is how you do tangent. Next up, we're going to look at cotangent. So just to give you a reminder, cotangent looks pretty similar to tangent, but it decreases the whole time instead of increasing. And one period's from 0 to pi. So it's slightly different there. And let me show you the Desmos version. And once again, we'll see how this transforms. All right, so here's our Desmos for cotangent. You can see there's one period from 0 to pi. You can see it decreases in that interval. If I change the a value, the number multiplied in front of the cotangent, take a look at what happens. Just like with tangent, it stretches or compresses vertically or flips upside down if a is negative. And b, as you might expect, is going to change the period. But notice where it's kind of anchored this time, where it stretches from. So just like every single trig function, something they all have in common is that this is going to be anchored at 0, at x equals 0. So this time, just like most of the trig functions except for tangent, the first x value is going to be 0. So that's something that we are going to make sure we track. So let's go back to the notes and try that. All right, so I want you to write this down. Cotangent is the same as tangent, the same process as tangent, except that the first x value is always 0. I mean, the graph is also slightly different, right? It goes down instead of up. So if you want to write something about that, you can, but we're just going to always go based off of the parent graphs. I will write that here. I'll write that the parent decreases instead of increases. Okay, so let's try this. We are going to start by identifying a and b, just like always. And I see that a is 2 and b is 1/3. So I'm going to figure out what is my vertical stretch. It's just whatever a is. So this time it's 2. My period, just like with tangent, is pi over b. So it's going to be pi over 1/3. And that means it's pi times 3 over 1. We multiply by the reciprocal, and that's 3 pi. And so if I make my chart of key points, this time instead of being centered at 0, the parent graph starts at 0. So we are going to put the first value at 0, just like the original version. Started at 0. The original ended at pi because the period was pi. Our period's now 3 pi, so we're going to go all the way to 3 pi. And then we're going to split that interval into fourths. So half of 3 pi is 3 pi over 2. Half of that is 3 pi over 4. And half of between 3 pi over 2 and 3 pi is 9 pi over 4. You can use your calculator to calculate those if you want. Now we need y values. So we take the original and we multiply them by the a. So our a is 2 this time. So first we're going to have the vertical asymptote. 1 times 2 is 2. 0 times 0. 0 times 2 is 0. Negative 1 times 2 is -2. And then we have the vertical asymptote again. All right, so now we're going to graph. It's going to look pretty similar to this, except stretched. So I already made my axes here. First, I'm going to make my vertical asymptotes at 0 and 3 pi. Then I'm going to plot the points. So 3 pi over 4 is at 2. 3 pi over 2 is at 0. 9 pi over 4 is at -2. And I connect the dots. And there we go, okay? So that is how you graph tangent and cotangent. You now have enough information to do the whole worksheet. Make sure you check your answers. And if you get stuck, check the answers as you go for guidance. And we'll go over any questions that you have during our next class. All right, thanks very much. Have a great day.